Hello and welcome to part 6 of the chapter Triangles. Today, under application of BPT and areas of similar triangle, we are going to study numerical problems. Till last year, the distribution of marks was 1, that is objective question, 3 for theorem, and 3 for rider. So there was no much scope for the numerical problems. This year, there is a little more scope for asking numerical problem. Maximum it can be of 6 marks. So let's start the numerical problems. This is the figure given and here is the question. In the adjoining figure, DE is parallel to BC. If AD is equal to 7, AE is equal to 28 centimeters and EC is equal to 20 centimeters, then find DB and AB. See, since D is parallel to BC, we can straight away go for the BPT. So according to BPT, it is AD upon DB is equal to AE upon EC. So we'll substitute 7 upon X is equal to 28 upon 20. Therefore, X is equal to 7 into 20 upon 28. 7 4s are 28, 4 5s are 20. So you will get X is equal to 5. So since X is equal to 5, you will get dB is equal to 5. We are also asked AB. So AB will be 7, that is AD plus DB. So that is 7 plus 5 is equal to 12 centimeters. This can be objective question for 1 mark, or this can be short answer type numerical problem for 2 marks. So let's go ahead and see more examples on BPT. In triangle ABC, P and Q are points on side AC and BC respectively. If CP is equal to 4.9 centimeters, PA is equal to 3.5 centimeters, CQ is equal to 5.5 centimeters, and QB is equal to 2.5 centimeters, then find whether AB is parallel to PQ. This is based on the converse of BPT. If ratios are equal, then only we'll get PQ is parallel to AB. So let's find a ratio. First ratio is CP upon PA. And we get 4.9 upon 3.5, which can be written as 49 upon 35. So 7 7s are 49, 7 5s are 35. Let's go to the 7 upon 5 is the ratio. Let's go to the other ratio. CQ upon QB, which is 5.5 upon 2.5, which is 55 upon 25. Common factor is 5, so you will get 11 upon 5. So what you find is the two ratios are not equal. So since ratios are not equal, AB is not parallel to PQ. This is a converse of BPT. Let's go to the third example. So in the third example, in triangle ABC, PQ is parallel to BC. So it's obvious we can apply BPT here directly. AB is 6, PB is 3 centimeters, QC is 5 centimeters, find AQ. Here if you look at carefully, you will find that AP is not given. AP is AB minus PB. So you get 3. That you have to find first, and then we'll go for the BPT. That is AP upon PB is equal to AQ upon QC. So it is 3 upon 3 is equal to x upon 5. 3 will get cancelled. Cross multiply 5 and you will get x is equal to 5. Therefore, AQ is equal to 5. Let's go to the next example. I think this is on the application of areas of similar triangles theorem. There are two similar triangles. So, and the areas are respectively 25 and 49. And one side of triangle EF is given. You have to find the corresponding side of the other triangle, that is BC. Let's go to the basics. What this theorem says is ratio of areas of two triangles, that is area triangle ABC upon area triangle DEF is equal to squares of their corresponding sides. So you are asked to find BC. So BC and it is corresponding to EF, which is given. So let's substitute here. 25 upon 49 is equal to BC square upon 9.8 square. Rearrange the term. It will be 25 into 9.8 into 9.8 because it is 9.8 square upon 49. So we have to find BC. So it will be square root. Put this square root for the, this square root is for the entire bracket. That is 25 into 9.8 into 9.8 upon 49. So square root of 25 is 5. 9.8 into 9.8 under square root sign. So we will get 9.8 out of the bracket. And square root of 49 is 7. So let's see the next step. We will get it like this. 5 into 9.8 upon 7. You can cancel 7 and 9.8. 7 1 is 7. 7 4 is 28. So you get 5 into 1.4 is equal to 7 centimeters. This can be again a 2 marks question or it can be an objective question of 1 mark. Sides of two similar triangles are in the ratio 4:9. Please take care here. 9 is gone on the next line. It is 4:9. Find a ratio of the areas. Now here in the previous example you must have seen we find a square root. So many times since 4 and 9 are perfect squares, you go directly and write 2 and 3, 2:3. But you have to go to the always basics. Here what is given is the ratio of the sides which we have to square. When sides are asked to find out, we have to find a square root. But when sides are given, we have to square them. Let's go to the basic. Don't try to solve this mentally. Area triangle 1 upon area triangle 2 is equal to a square upon b square. And what is given to us? The ratio of the sides is 4:9. So 4 square upon 9 square. So ratio of the areas will be 16 upon 81. Next example. Ratio of the areas of two triangles is 16:81. In triangle DE parallel to BC. Now let's see the figure first. In triangle ABC, DE is parallel to BC. DE is 3, BC is 6, and area triangle ADE is 15 centimeters square. Find area triangle ABC. Though it is given parallel, we cannot use here BPT because this deals with the areas of the triangles. You are given area of one triangle and corresponding side of both the triangles. So you can use here areas of similar triangle theorem, but the problem is you are not given the two triangles are similar. This is actually a 3-mark question in the model paper sent by the board. So how to do this? This is slightly, it is rider come numerical example, because we cannot use areas of similar triangle theorem unless we prove the two triangles similar. And the two triangles are triangle ABC, the whole triangle, and the second is triangle ADE. We take these two triangles. The reason is we know area of triangle ADE. One reason, we are asked to find area of triangle ABC. And if you look at the sides which are given, they are the corresponding sides of the two triangles. Let's see. In both the triangles, that is the entire triangle and the triangle ADE, there is common angle is there. A is equal to angle A, common angle. And you can see here, triangle ABC, here down, is equal to angle ADE. They are the corresponding angles. Why corresponding angles are equal here? It is given as DE is parallel to BC. So from these two steps, we prove triangle ABC is similar to triangle ADE by AA criterion. Now we are free to use the theorem areas of similar triangles. And the theorem is area triangle ABC upon area triangle ADE is equal to BC square upon DE square. Let's substitute. Area triangle ABC is asked to find out upon 15, that is given to you. BC is 6 and 6 square upon 3 square. So you get area triangle ABC is equal to 36, that is 6 square, into 15, that is cross multiply 15, upon 3 square, 9. You can cancel 9 and 36. 9 4s are 36. So you will get 4 into 15, 60 centimeters square. Area triangle ABC is 60 centimeters square. This is application, that is a rider part, as well as there is a numerical part. It is not very difficult. Go through this very carefully. Look at the steps. Why? Because we cannot use, which we used in the earlier two examples, areas of similar triangle theorem. We cannot use it here because we are not given the two triangles are similar. Instead of that, we are given the DE is parallel to BC, which can be used to prove the two triangles are similar. Take down the homework. There are two examples for the homework. Most of the examples which we have solved today or which are asked in the homework are from the board paper. So you will get an idea of what examples, what numerical examples are asked based on the theorems. So that's all for today. Next time, first we will do the homework and then we will go for the applications of other two theorems, and that is Pythagoras theorem and converse of Pythagoras theorem. Thank you.